Hello and welcome to Engineers Mindset Academy. So this is the fourth video we are making on Laplace transformation. The very first three videos we actually introduced Laplace transformation and stating the 7 table of standard values which we need to do any analysis involving Laplace transformation. So do well to watch all the videos for proper understanding, because we are going to be connecting dots from that particular video, those videos, into this particular video. Today's video we are going to be talking about inverse Laplace transformation. Now, what is the idea of inverse Laplace transformation? It is simply the values obtained when you take the inverse of a given Laplace transform. For instance, in the table of standard value, which I've talked about in the previous videos, in the previous 3 videos involving Laplace transformation, I said the first is the Laplace of a constant. So if you're asked to find Laplace of 5, this simply means what? 5 all over s. The Laplace of 5 automatically from the table of standard value is what? 5 all over x. So which means if you're asked to find the inverse, Laplace inverse, so this symbol simply means Laplace inverse. If you're given to find Laplace inverse of 5 all over s, automatically the answer is equal to 5. Hence, the inverse of the Laplace transform of a given function becomes what? The Laplace inverse of that value. So if you're asked to find the Laplace inverse of 5 over x, automatically the answer is equal to 5. Now, the second table of standard value we talked about is the Laplace of an exponential function. I said if you're asked to find the Laplace of, let's say, exponential at, this is actually, we agreed in that video, or we solved, that this will give us 1 all over s minus a. So this simply means that if I'm asked to find the Laplace of exponential 3t, this is equal to what? 1 all over s minus 3, where a is equal to 3, or the number attached to the exponential function. Therefore, if I'm now asked to find the Laplace inverse of what? 1 all over s minus 3, automatically I should know that the Laplace inverse of this should give me what? Exponential 3t, because the Laplace of exponential 3t simply gives us 1 all over x minus 3. Hence, Laplace inverse of 1 over x minus 3 is simply what? Exponential 3t. If I'm also asked to find the Laplace inverse of 1 all over s minus 6, automatically this is what? Exponential 6t. That becomes the answer. Okay, if I'm also asked to find the Laplace inverse of 2 all over s minus 4, this is very simple. Why? This is simply equal to Laplace inverse of 2. You can now factor out 2 multiplying by 1 all over s minus 4. And since this is multiplication, it means you cannot find the Laplace inverse of 2, because 2 is multiplying everything here. So all you need to do is to what? Pull out the 2 from the Laplace inverse. Therefore, I will have 2 Laplace inverse of 1 all over s minus 4. And I know that 1 over s minus 4, the Laplace inverse will simply give me what? Exponential 4. That means this is actually equal to 2 times exponential what? 4t. That becomes the answer. Hence, the inverse of a given Laplace transformation gives you the Laplace inverse of that given function. Alright, the third table of standard value which I talked about, okay, is the Laplace of a function raised to an integer. So I simply said Laplace of t to the power of n, and we agreed that this is actually what? N factorial all over s to the power of n plus 1. Hence, if I'm asked to find the Laplace of t to the power of 3, this is actually what? 3 factorial all over s to the power of 3 plus 1. So this is equal to, what is 3 factorial? I have 3 times 2 times 1 all over s to the power of 3 plus 1 here will give me 4. So this is equal to 3 times 2 is 6. 6 times 1 remains 6 all over s to the power of 4. So automatically, if I'm asked to find the Laplace inverse of 6 over s to the power of 4, I should be able to know that the answer is equal to t to the power of 3. It's as simple as this. If I'm asked to find the Laplace inverse of 24 over s to the power of 5. Now, if I'm asked to find the Laplace inverse of 24 all over s to the power of 5, I should know that from the formula n factorial over x n plus 1. So which means 1 was added to what? This n, which means that n itself is equal to what? 4. automatically this simply means that n is equal to 4, because from the formula s n plus 1, and I'm having this to be equal to s to the power of 5. So that means n was given as 4, so it became what? S4 plus 1, and that's how we got s to the power of what? 5. Hence n is equal to what? 5, and this should automatically give me t to the power of 4. N is equal to 4, please. So this should give me t to the power of 4. Hence the Laplace inverse of that function is automatically t to the power of 4. Also, the fourth table of standard value which I talked about is the Laplace of sine at, okay, and we said Laplace of sine at automatically is given as a all over x squared plus a all squared. So let's say we're asked to find the Laplace of sine 5t. So this is actually what? 5 all over x squared plus 5 all squared. Therefore, Laplace of sine 5t is equal to what? 5 all over x squared plus 5 squared there will give us what? 25. So if I'm given a question and I'm asked to find the Laplace inverse of s of 5 all over x squared plus 25, I should be able to know that this is what? Simply sine 5t. Okay, if I'm asked to find Laplace inverse of 5 over x squared plus 25, I should be able to know that this is sine 5t. Similarly, if I'm asked to find the Laplace inverse of, let's say, 7 over x squared plus 49, I can easily break this down. This is Laplace inverse of 7 over x squared plus 7 squared will give me what? 49. So this is plus 7 squared. And of course, if I have this, comparing this to the formula above, okay, I will simply have that Laplace inverse of that function is what? Sine 7t. So it's as simple as this. The fifth thing I talked about in that video is the Laplace of cosine function. So let's say we're asked to find Laplace of, okay, cos at, and I simply said this will give us s all over x squared plus a all squared. We already did all of this in the previous 3 videos. Okay, so that means if I'm asked to find Laplace of cos 5t, it is simply equal to what? S all over x squared plus 5 all squared. So this is actually s all over x squared plus 25, because 5 squared is 25. If I'm asked to find Laplace of cos 3t, so this is equal to s all over x squared plus 3 squared, which will give me s all over what? X squared plus 9. So therefore, if I'm asked to find the Laplace inverse of s all over x squared plus 16, if I'm asked to find the Laplace inverse of x over s squared plus 16, I should know that this is Laplace inverse of s all over x squared plus 4 squared will give me 16. So I have 4 squared. So having this notation, automatically my mind should be drawn to this s over s squared plus a squared, which is this. So this simply means that we have this to be what? Cos 4t. The answer is simply cos 4t. Okay, so the 6th table of standard value we talked about in the previous 3 videos is we have the Laplace of hyperbolic sine. So if I'm asked to find sine at, I simply said this is equal to a all over x squared minus a all squared. So if you're asked to find the Laplace of sine 4t, this is actually equal to what? A there stands for the number, which is 4 all over x squared minus 4 squared. So this is automatically 4 all over x squared minus 4 squared there is what? 16. So if I'm asked to find the Laplace inverse of 4 over x squared minus 16, automatically I should know, immediately I see the sign changes under here from positive to what? Negative. It becomes now no longer sine but rather a hyperbolic sign, which is now sine. So this should tell me already that this is actually what? Sine 4t. Okay, similarly, if I'm asked to find the Laplace inverse of 8 all over x squared minus 64, okay, 8 over x squared minus 64, again, since I'm seeing negative sign here, automatically I should know that this is what? Sine 8t, and not sine. This is sine 8t. Okay, finally, the seventh standard table of standard value we talked about is the Laplace of hyperbolic cos. So if you're asked to find cos 8t, Laplace of cos 8t, we simply say this is now s all over x minus x squared minus a all squared. Okay, so if I'm asked to find the Laplace of cos 5t, this is actually what? S all over x squared minus 5 all squared, and this is simply s all over x squared minus 25. Okay, hence if you're asked to find the Laplace inverse of s all over x squared minus 9, okay, if I'm asked to find the Laplace inverse of x over x squared minus 9, the fact that I'm seeing x here and not a number automatically should tell me that this is what? A hyperbolic function of cos or cosine. So this is now equal to what? Cos 3, because 3 squared is what will give me 9. Alright, so that's the idea behind inverse of Laplace transformation. Okay, so we are going to be making use of all of these terms we learned here in the inverse transform, and those will land in the standard table of standard values from the very first beginning of the video down to this particular video. We're going to be combining all of them into the next topic, which we are going to be dealing with under Laplace transformation. All right, I will see you in the next topic. Thanks and cheers.